Hello, it's Mr. Wolf, and in this video I am going to be going over a proportional reasoning problem with energy. So I'm specifically going to go over number 2 in the proportional reasoning practice worksheet. And in the problem it says that a semi-truck is driving down Half-Day Road when it sees a red light, applies its brakes for 21 meters as it comes to a stop. Right? A car instead of a truck, or a semi-truck, with 1/4 the mass was driving the same speed when it saw the red light, and it applies the same braking force to come to a stop. All right? The question is, by what factor is the car's distance going to be different than the semi-truck's distance? All right, so the nice thing is if you notice, it's the same exact situation in terms of my energies. The only difference here is the mass. So if I look at my beginning situation, driving down Half-Day Road is on the ground, so no potential energy. They're moving, so I know I'm going to have some kinetic energy. Right? As long as you could put 4 blocks, you could put 2 blocks. I'm going to put 3. Right? And then it looks like they come to a stop at the end. So there's no kinetic energy at the end. And I'm still on the ground on Half-Day Road, so no potential energy. Right? So just kind of logically, since you can't create or destroy energy, I know that I have to have energy leave my system. Work has to be done. Right? So I'm going to say that, okay, I'm going to have 3 blocks leave my system because logically that just had to happen. Additionally, it says that there's a braking force that's causing this truck or car to come to a stop, which means, again, work equals force times distance. So that kind of makes sense that work would be leaving my system. So there's 2 ways I could figure out that work's leaving in this sense. Also, because friction would cause energy to leave, the car or truck as it comes to a stop. All right, so work caused by force of friction. All right, so there's my LOL. It's the same LOL for the car and the semi-truck in terms of setting up our equation. All right, so for kinetic K, no UG, in this case, minus work is equal to, and then there's nothing, so 0. All right, my variables end up being 1/2 mv squared. Work is force times distance is equal to 0. All right, so now let's actually do some proportional reasoning now that we've set up this problem. So I'm going to just rewrite my problem again. Or I may not rewrite it, but let's see, 1/2 mv squared minus force times distance is equal to 0. Okay. So in terms of solving this, it kind of becomes a little bit difficult when you have a 0 at the end. So this is what I recommend doing, is you have just 2 energies equal to each other. And since this is minus force times distance, what we could do is we could just add force times distance to both sides. So it cancels out over here. And then now I have plus force times distance over here. So to kind of rewrite that, it's 1/2 mv squared is equal to force times distance. That's just a whole lot easier to work with. All right, so since I'm doing proportional reasoning, constants, I don't care about them, so I'm just not even going to bring them down. The mass in this case, if I'm talking about the car, it's 1/4 as much as the truck was, right? The velocity, right, it looks like they're driving the same speed initially, and this is my initial kinetic energy, so I'm going to put in 1 in for velocity. And then they apply the same braking force, so that's going to be 1. And my distance is going to be, that's what I'm looking for. By what factor is the car's distance going to change? So distance goes right there. All right. Now notice that it did give me another number, 21 meters, but that's an actual number. So something I didn't do that I think is always a helpful thing to do is kind of draw your actual numbers and your factors. And remember, you can't mix these 2 together. So my actual number, since there's a unit behind it, my distance is equal to 21 meters. My factors are the mass is 1/4 as much, the velocity is the same, and my force is the same. All right? I'm looking for the factor that my distance changes. So you can't bring in this actual number into this problem where I'm including a bunch of factors. All right. So I've set up all my factors. Now I'm just going to solve for distance. All right, 1 squared is 1 times 1/4. So it ends up being distance is equal to 1/4 in this case. In other words, my distance is 1/4 as much it takes 1/4 the distance to stop for the car because it has less mass compared to the truck, which just has more mass. All right. So how long does it actually take the car to stop? Well, what I could do is I could say, well, it took the truck 21 meters to stop. The car stops in 1/4 that distance. So that ends up being 5.25 meters for the car to stop. So it's still very similar, proportional reasoning, right, in terms of using the one-on-one method, getting rid of factors, constants, making sure you don't mix actual numbers and factors. The only kind of new thing is making sure that you could write your equation before you start proportional reasoning. Thanks for watching.